I guess so I was getting my recording started back up again. Well, it looks like the people entering here is kind of slowed down and everything. Got a little announcement to make there for people that might not be aware. The state released an IU there, allowing agencies to go back to work. And they've kind of listed some guidelines there. And one of them, if you got questions, get a hold of the technical subcommittee on that if you got questions. And Jeremy Bald there is the head of the technical subcommittee there, so you probably need to reach out to him on that. And we're going to be sending out an email as well to everybody. And if you could there, let us know when you guys are going back to work and, you know, what kind of training and stuff there you guys might want. If somebody's on here and, you know, their boss, their energy coordinator and stuff's not on here and stuff, when you talk to them, if you let them know. I think the emails already went out to them. But we would really appreciate that. And I guess we're just going to kind of wait and see. I know people's going to have to figure out a few things. I don't think anybody's going to hop right back to work here real soon into houses, but I do know a couple agencies actually did go back there yesterday. So with that being said, if everybody could just mute themselves there. If you guys got questions, that's fine to unmute yourself there and come in and ask the question and everything, but if you could just keep yourself muted until then. Today, what we're going to be going over there is HVAC system inspection or heating unit inspection on that. The HVAC equipment needs to be documented, and its general condition and age needs to be evaluated, and the following items should be gathered. Record the type of HVAC system, model number, serial number, rated efficiency, if available, and the location of the heating and cooling system. And here's a data plate on here. You know, you look on this data plate here, you can get the information, the model number, serial number. And if you look at this, obviously this is an electric air handler on this. You see the voltage on there, 208, 230, and everything like that. I'm going to say this is also for a heat pump. I see refrigerant R22 on here with this. And the manufacturing date, 2006, okay? If you can get this information on here and everything, that's great. All right, one of the big things we are worried about there with our combustion appliances there is carbon monoxide testing. And this is a warning label there and stuff that's going to be on all your appliances on there. Just about all your combustion appliances, hot water tanks, furnaces and stuff has some type of warning labels on there about dangers of carbon monoxide. That's one of the first things we're going to kind of get into here. Carbon monoxide testing requirements. Some things there you need to remember. Since these are just snapshot tests, they will not reflect how the equipment will operate under all conditions. 3 overlapping test requirements in the standard are to test the combustion appliances flue gases for CO, examine the accessible venting system, looking for damage or leaks in the vents where they might be disconnected and so forth, and perform a combustion appliance zone test or CAS test on their worst case. And technicians need to measure and record the carbon monoxide levels and perform testing designed to evaluate if the combustion gas venting system is operating in a safe manner. CO testing tools on there. You need to have a combustion analyzer there that's going to be capable of measuring carbon monoxide levels from 0 to 2,000 parts per million in there, and have a resolution of 1 part per million or better. And these are typical. Just about any commercial carbon monoxide detector that you get is going to have these requirements in here. An accuracy rate of plus or minus 5% or plus or minus 10 ppm. They should have a nitric oxide filter in there or a NOx filter. Basically, what that does is filter out the NOx gas in the flue gases, which can affect your CO readings in there. Every combustion appliance will emit some type of nitrous oxide in there. So, and if you don't have one of those filters in there, it can affect how your CO reading is. Be calibrated annually by the manufacturer and have evidence of the calibration. Okay. It doesn't have to necessarily be by the manufacturer. It could be by another outfit there that's certified to calibrate those. When you're doing CO tests, if the ambient CO levels of 35 part per million are detected, the technician shall stop all CO testing and depressurization testing. Okay. So that's when you're starting to reach the dangerous levels there and stuff when you get to 35 parts per million. On that. If that's out in the ambient air and stuff, you've got some major issues going on, either from backdrafting or disconnected vent or just something going on. So it needs to be examined further before you continue any of the testing. One thing you want to do is measure the outdoor CO level before entering the home. This measurement will be your baseline on there. There is no requirement for the inside CO level to be lower than the outside CO reading. So, you know, if you measure the outside CO reading there and you've got 9 parts per million outside, you know, if it's 9 parts per million inside there, that's your base level on that. You know, and CO testing inside the home should be ongoing during the combustion appliance CAS test and during all CO testing on that. And basically, when they're talking about CO testing there and stuff, it depends. Here in the weatherization there and stuff, we've never really done our CO testing under the worst case conditions in this. That is something I think we're going to be moving forward on with the new worst case draft coming out. So we're actually going to be measuring our CO readings and doing our combustion analysis here and stuff there in the worst case scenario. And that's to align with the SWS and BPI standards, and even the NFPA 54 standard. Whenever there are atmospherically vented appliances, following directions for testing those appliances need to be followed. Okay. Take a measurement of the combustion gases at the flue before the draft diverter and around the external perimeter of an accessible vent piping joints. Okay. That would be like the draft diverter on a hot water tank. Get in underneath that draft diverter there and get your reading on that. Can't take it in the vent pipe. The appliance must be in operation for at least 5 minutes or until it's reached steady state before you take the reading. And steady state's when the stack temperature is leveled off on that and not climbing more than 1 or 2 degrees there per minute. And here's an example there of a Bell draft diverter that you see a lot there on boilers. Some of the older hot water tanks there actually have these on here and stuff. And this is kind of giving you the setup on this. You know, your exhaust gases, where this arrow is going in here is where you want to sample them. And basically you got your dilution air coming in up underneath that and everything. Another one there, you can see where the arrow's pointing in. You want to get a reading here in this, below this draft diverter on that, because we want to get an undiluted sample of this CO. We don't want to take it after the draft diverter there, because that's when we're going to be getting a diluted sample. For the vented appliances, the following tests need to be completed. Measurement of combustion gases must be taken at a vent connection and around the external perimeter of accessible vent pipe joints. Appliances must be operating again for 5 minutes there to reach steady state before getting the sample. For unvented heating combustion appliances, measurement of combustion gases must be taken from the area surrounding the appliance. The appliance must operate for at least 5 minutes or reach steady state before taking the sample. Acceptable emissions from unvented combustion appliances shall be based on A-5 That's an Appendix 5 there in your High Weatherization Field Guide, and that's located on page 487. There was also a chart in the back of your NFPA 54 there that aligns with that, but all those readings in that's going to be air-free, and that's something we're going to talk about here later on. That is for carbon monoxide from unvented gas room heaters and fireplaces, also referred to as vent-free room heaters or fireplaces. And here's an example of the CO threshold limit here out of NFPA 54. Again, this aligns exactly with what's in our field guide and everything as far as their free readings and stuff. The only difference is we also have the option here for our appliances like your central furnace and stuff there to have the as measured readings on here, which is going to be a little different. We're going to kind of go over the equation as what they're talking about air-free readings and as measured readings, what the difference is. Gas ovens need to be tested. The following tests apply. Remove any foil or cooking utensils within the oven. Okay, we always want to sit there and make sure there's nothing in the oven there or nothing in the warming tray and stuff. I think we all know. A lot of times people come on here and, you know, they stick their dirty dishes in there, kids' toys, shoes, you know, whatever. So you always want to check to make sure there's nothing in that oven before you test it. Verify that the oven is not on self-cleaning mode on there, but turn the oven on the highest temperature setting on there. And you notice that says oven, not broiler. So, and the reason why they're doing that, the oven's the most usual burner that's used on that. And basically that kind of aligns with NFPA 54, BPI standards, and the SWS as well. Gas ovens need to be tested and the following test applied. Close the oven door and begin monitoring the CO levels in the kitchen, 5 feet away from the oven at waist height. This is where a personal CO monitor comes in play, okay? When you turn that oven on there and stuff, you need to have it go through a warm-up cycle there of at least 5 minutes on there before it reaches steady state. You don't want to stick your analyzer probe in that oven before it levels off, because you're going to get a real high spike in CO typically when that oven first lights off. And if you do that there, the more CO your combustion analyzer sees, and that CO sensor in your combustion analyzer, the shorter the life's going to be on that sensor in there. Possibly more often you're going to need to get it calibrated to have accurate readings. But again, there, as far as monitoring the ambient CO, there's that number, 35 parts per million again, okay? Anytime there the ambient level gets above that 35 parts per million in there, you need to stop the testing and have the oven repaired if possible before you continue on that. Measure the CO levels within the oven vent. Again, basically you're going to find where that vent is on that oven. It could be right back behind the top burners on there. It could be coming up in between the burners on the top of it. I've seen it in several different spots. I've even seen them with the vents on the back of it in there. So that's something you want to watch for. And samples must be taken while the burner is firing. And this is one thing I'm going to stress a lot. When we see people testing here at the test center there and stuff, or the training center, for their BPI and everything, we notice a lot of people when they go to take an oven reading, they'll turn it on and they wait till the oven shuts off before they take their CO reading. You're not getting an accurate reading of the burner operation on that oven when you do that. You need to take a reading before that oven shuts off. If it would happen to shut off on you, you need to open the oven door and let it cool off and fire back up again before you take a reading on that. And again, there it's talking about the burner should operate there for at least 5 minutes on that before sampling flue gases. CO verification for appliances tested shall be compared to the threshold limits in A5 in the High Weatherization Field Guide on there, page 487. For threshold limits and air-free units, a measurement device set to air-free setting must be used, or one of the two formulas may be used based on measurements from the combustion analyzer. And just about every combustion analyzer you get now has the capability of measuring this stuff air-free on that. And again, that's something I think we're going to move more and more toward. It's already kind of an industry standard as far as what furnace manufacturers look for and stuff like that. That's the reason air-free readings what's listed in FPA 54. And again, here, this is this chart here out of NFPA 54, and it's talking about the air-free emission levels are based on mathematical equation, either involving the carbon monoxide and the oxygen or carbon monoxide readings on that. To convert an actual diluted flue gas carbon monoxide testing sample to undiluted air-free flue gases, carbon level utilized in the appliance certification standards. Okay. And if you look at table 1 there in your National Fuel Gas Code, table 6, I'm sorry, on that. Air-free emission levels are based on mathematical equation, again, involving carbon monoxide and oxygen or carbon monoxide readings to convert a actual diluted flue gas carbon monoxide testing sample to an undiluted air-free flue gas carbon level utilized in the appliance on that. And I'm going to kind of touch base on these formulas here and stuff in a second on that. But the CO verification for the appliances tested shall be compared to the threshold limits again. The same ones that's in NFPA 54 is listed in the field guide in Appendix 5, page 487 on that. And it lists all the air-free readings on that. If you go on else into the field guide there and stuff, it actually gives you as measured readings there you could go by as well. If you want to take the air-free reading, the easiest thing is to have the device set up there to give you an air-free reading on that. Like I say, most of the combustion analyzers made in the last 20 years will be able to do that for you. And when the manufacturer's testing instructions are available, always use the manufacturer's instructions. When they are not available, the exhaust gas should be tested near the center of the exhaust stream in the exhaust duct. A test hole is generally required. However, when one is in there, it must be sealed when the testing's complete. So we don't want to walk away and just leave a hole in there, okay? Not necessarily that it's going to hurt anything, because most of the appliances, atmospheric appliances and stuff like that, have a negative vent pressure in there. It didn't have to worry anything there if the appliance is venting correctly, but if it's not, you could, that's another opening there where you could get backdrafting coming in. And here's the formulas here where they're talking about the carbon monoxide air-free. May be calculated using one of the following formulas on that. This one here is going to be using there if you're measuring the CO2 carbon dioxide in this. For the most part there, most of the analyzers here and everything, what they have is an oxygen sensor and a CO sensor in that. So, this is the big one I'm going to be hitting on there. And basically what you're going to do is take 20.9, that's the percentage of air that's in the Earth's atmosphere at sea level, okay? And then we're going to take our oxygen reading off of that appliance there as we're reading it and subtract that from the 20.9 and divide this number we get right here, or divide 20.9 by this number we get right here, and then multiply that by our CO as measured reading. And this is kind of talking about what everything is: carbon monoxide, air-free parts per million, CO2, okay, CO ppm. That's the measured concentration of carbon monoxide combustion products in percentage. O2, that's the measured percentage of oxygen in the combustion gases. and then the ultimate concentration of carbon dioxide on there, okay? Every combustion process produces carbon monoxide, or dioxide, I'm sorry, on there. The only time we get carbon monoxide being produced is when we have incomplete combustion. And here's showing, taking a reading here using the CO2 one. Again, I think if somebody's analyzer had to do this, you had to actually do this calculation stuff. We're going to be using the oxygen one. So I'm just showing this here to you guys so you kind of have a reference as to what they're talking about. And this other one here is measured to O2 at 10.9% by volume in the exhaust gases, and the CO at 100 parts per million. In the exhaust gas of a floor furnace using natural gas. And they want to know, does it meet the 400 parts per million table value? So if you do the math on this and everything there, basically your air-free reading is going to come out here as 177.65 or 178 parts per million. And that's going to be well below the 400 parts per million air-free. And where the CO exceeds the threshold limits, the following safety measures must be done, okay? Notify the client there the need to call a qualified technician to have the appliance repaired or tuned, okay? Document that the equipment is unsafe for continued operation in there, and document that the client was informed of this condition. Now, we don't necessarily want to be flipping out everybody on this here and stuff and necessarily turning it off if they have a high CO reading there, especially if it's in the middle of winter. The key thing is when we do our worst case draft testing and everything, that CO is actually spilling out and coming out into the ambient air. That's when the problem's going to be, okay, on that. But it is important there, if we have something producing high CO and everything, we don't want to do any air sealing measures and stuff there until the problems that are causing that CO concentration has been eliminated. Because as we seal that up, even if that thing's not backdrafting there and coming out into the ambient air, as we seal it up and stuff there, we could cause it to when we do our worst case. So we want to have a written record there, the CO measurements for each step listed on the previous slides that were required shall be kept in job file, okay? Something you guys do on every job. You go out there and get your data collection form there and stuff, and you record all these readings. You know, some other things we're looking at here on these readings, just not CO, is our oxygen reading, of course, our stack temp, and our steady state reading on that. Those are the main readings we're really concerned about. So, you know, if we have those 4 readings on there, 5 readings on there and stuff, that's going to be able to tell us a lot of what's going on with that appliance in there. Measurements or calculations for each combustion appliance in the home should be based on air-free or as measured requirements. Evidence of the homeowner notification, okay? If they do have a problem, we want to let them know that there is a problem, okay? And again, try to get that we're going to get there and repair it or possibly replace the unit or something as soon as possible on there. And evidence of repair work done before home performance improvements there were implemented, okay? Again, that's been our rule here in the weatherization program for a long time. All health and safety issues need to be taken care of before any weatherization takes place. And here, I've got a video there of going through a combustion analysis on a hot water tank and a 80+ furnace on this. So hopefully everybody's got some popcorn or something to snack on here and they can watch me real quick. All right, I'm going to be going through some combustion testing with you and everything. We got our combustion analyzer there. Also have personal CO alarm. Anytime you're doing any type of combustion testing, whether it's worst case or just doing a combustion analysis, you should have one of these for your personal protection on. doing the combustion analysis on this here and stuff, I'm going to start off with a hot water tank at the lowest BTU appliance. So I'm going to fire this off. And my analyzer is already warmed up and ready to go here. On this one side, I'm lucky, I've got a hole in right there where I can get right down into the fire tube on this water heater. This other side here, I'm going to kind of have to hold it and angle it up. And what I want to do there is wait till this thing reaches steady state, or approximately about 5 minutes to take my reading. I know in NFPA 54, BPI standards and everything, they want you to take the reading at 5 minutes of main burner operation. Either that or pay attention to the stack temperature, and when stack temperature starts leveling off, that's when it's reached steady state. So. And as we can see here, we got an oxygen reading here of about 5.40 CO. This first reading here on the CO is the CO as measured. It's 0. The CO with the little O in parentheses is CO air free. And that one's actually 0. So that's telling me this hot water tank is burning really efficiently. Alright, this stack temp's leveled off here fairly good. I'm going to go ahead and hit hold on this and look at my readings there. I've got an oxygen reading there of about 5.3%. Basically, on an atmospheric appliance there and stuff, I'm looking for a reading there between 5 and 10 on that. CO is 0, so it's perfect. I've got a copy out of the annex here of the NFPA 54 here, which gives you CO readings in air-free measurements. And if we look at a water heater on this here and stuff, it says 200. So we're at 0, so we're good on this side. But with a hot water tank, we want to get a reading on both sides of the baffle in here. So I've got to go over to this other side here now and try to get a reading. It's not uncommon for these things to vary from side to side, depending on whether the burner's a little cockeyed in there or has some dirt down on one side of it or whatever. So I'm still kind of noticing here, my CO's still 0 on this. The stack temperatures went up a little bit here on this, which is affecting my efficiency. My O2 still in really good shape on that. So, yeah, basically now I can go ahead and hit hold on that, record my readings. Nice thing about this backer rack there and everything there, there's actually an app there where you can download the readings on that instead of using a printer and actually email that to yourself. So now I'm going to turn this hot water tank off, and I'm going to get ready to fire my furnace off here on this. Get the thermostat, turn it on. Battery's starting to get low in my personal CO detector, so. And basically what I want to do here is wait until this fires off. I notice this door's not quite on here correctly, so I'm going to go ahead and put this door on. approximately 5 minutes after main burner operation. I don't necessarily want to stick my probe in there right away on fire off on a lot of appliances. So normally you get a big high burp of CO there coming off the initial fire up of the appliance. And with your CO sensor and these analyzers here and stuff, the more CO they see there, the less life they're going to have. And possibly the more frequent you're going to have to get them calibrated. And with this here, it doesn't really matter if you've got that pointed up in the air or down. We're reading the flue gases, not the pressure in the vent, so it doesn't really matter what direction that's in. And just so everybody knows, this analyzer is working correctly because now I'm actually getting a CO reading here on this furnace. This 80 plus furnace, I'm looking for a stack temperature here between 300 and 450 degrees on this. And that hot water tank there, I was looking between 300 and atmosphere. I'm thinking 475, so I have to check that to make sure. So. See here, CO's climbing up here pretty good already. The oxygen reading there is at 8.9. I'm looking for an oxygen reading between 6 and 9 ideally on this. In our standards, we're allowed between 4 and 9. There and stuff's allowed 400 parts per million air free on that. So I'm not anyways near close to that level yet on this. I still have a little bit more CO than what I'd like to see coming out of this. I'd like to see this closer to 0 than I would up in the hundreds as measured or 200s air free. And it's still continuing to want to climb here. Nice thing about this 80 plus furnace, you only got to take one reading in there. You're just getting a reading in the flue itself. Whereas with this atmospheric water heater there, we needed to get a reading, an undiluted reading down the side of the baffle plate. Taking a good while for this to start getting up to the stack temperature there on that. It's just now past 300, which is the lower limit on that. So I'm going to go ahead and probably give it another minute or so here before I worry about trying to take a reading on that. I'm going to see if it's going to go up any higher. Stack temperature looks like it's fairly leveled off there. It just jumped to 314, 312, but 316. And the CO is actually continuing to climb on this. I'm fluctuating around a little bit. Now it's coming back down some, so I'm at 82.2% efficiency. That's good. That's right at the kind of top level that I want to be at. This thing should never be above 83%. If you get above 83% efficiency in there, you could start getting condensation in your flue system. The CO, air freeze 241, CO as measured is 146. My stack temperature is 320, and my oxygen reading there is 8.3. So other than my CO being a little high on this here and everything, the readings they're all within spec, but I still don't like seeing that thing putting out that much CO. I'd like to see that CO a little bit lower on that. So right now I'm going to go turn this thermostat off. Things there, as I'm doing my inspection on this furnace, I'm going to be pulling my covers off, looking in here. So like I say, I'm producing CO, so I could start, having some soot accumulate in here around these burners and everything. This here's actually looking pretty good right now. I'd also pull it off and check the blower there. I'm not doing that because the blower is running right now there and stuff. But by doing all that, I can see if I'm going to have to call for anything to be done on this, if I am. And, I can have them go ahead and check this gas pressure on this appliance here. And that might possibly be able to take care of the CO. It could be something as simple as the gas pressure is not set exactly right on it. But again, I'm still within spec here according to our weatherization guidelines and NFPA 54, so if I wasn't going to call for anything else to be done to that furnace, I'd probably just let these readings go. All right, and that's going to conclude this on combustion analysis. All right, couple things in there. I kind of had a handicapped cameraman there right toward the end of that. I had him standing up a little too long. I apologize for that, Kevin. That's the reason why the video got just a little shaky there at the end. He's just coming off ankle surgery, so he's not back 100% yet. But hopefully nobody got motion sickness or anything from that shaking there right toward the end there. But again, hopefully that actually kind of showed you guys what you need to be looking for there, and you could kind of see the difference between the CO air free and the CO readings in that. I'll tell you what, I'll check on that just a minute there and stuff. I thought it was for the atmospheric appliances, wasn't it? Yeah, I'm pretty sure it's between 5 and 10. I'll have to grab my field guide. Is it? Okay. Yeah. Yeah, Dan's talking about fishing around in the vent for the high stack temperature. The big thing is you want to be in the center of the flow on that. So if you go in toward the center of the pipe, and that's what I was talking about, it doesn't really matter whether you're pointing up or down in that and stuff, as much as it is you're just in the center of that where you're in the center of flow. Okay, so the atmospheric was 5 to 10. Yeah, the atmospheric is 5 to 10 on that. So again, that's out of the high weatherization field guide. I know if you're working in warm choice there and stuff, they're still going off the old weatherization program standards, OWPS, on that time being. So they're still using a 4 to 9 on that, I believe. So another thing you want to do there when you're doing a heating unit inspection, and this is one of the critical ones there, and something you should probably do when you first walk in. You need to have on your gas leak detector in there and your personal CO alarm when you first walk into that house to make sure you're not exhibiting any hazards in there, anything. And using an electronic gas sniffer there and stuff, it's important to move slowly. You only want to cover about 1 inch there per second with that. Those electronic sensors in there and stuff, it takes a while for them to read any gases that might be leaking out. Typically what they do, a lot of times they read the difference in the air, not necessarily the gas itself in there. So as far as you doing that and everything, it's important to move slow. Remember, those things can be cross-sensitive to pipe dope, cobwebs, you know, a lot of different things there can set those off. So just because one goes off does not mean that there's a leak. If you look down there at the bottom, this is actually the gas line coming into the house there by the gas meter. And you can see, hey, they found a leak there. You can see all those bubbles in around that shutoff valve on that. And again, you want to have acceptable documentation on there. Anything we want to do, we want to record it, okay? If we find gas leaks and stuff there, we want to sit there and mark it. I suggest taking a piece of tape or ribbon or something, tying around where you found that gas leak, and then take pictures of it, okay? And those can be included in the work order. They definitely need to be kept in the job file in that. That way there, when you're sending that off either to the crew or to the contractor to go take care of that and stuff, they go there, they know they're looking for ribbons, and you take pictures of where those ribbons were and everything in that. That just gives them something else to kind of verify from in case somebody goes down, the homeowner goes down and says, well, what's this ribbon or this you know, piece of tape on here for, and pull it off before the technician or the contractor gets there. Unvented combustion appliances, okay? You know, those are allowed to be left in a home. They just cannot be the primary heat source. There's some other restrictions there according to NFPA 54 about their size and everything else, depending on their location. You know, they can't exceed over 6,000 BTUs in a bathroom, and is it 10,000 in a bedroom, Jim? I think it's 10,000 in a bedroom. I'd have to look in the thing there to be sure on that. So, and they can be a secondary heat source in there. We should not ever, ever, ever leave those in there as primary heat source. And we should, if we can actually convince the person there to actually remove that. You know, those are unvented. That doesn't mean that they're burning completely clean and efficient. Okay, most of the time they're not. Most of the time these burners and everything's covered with dust, and you know, if they got pets and everything, it could be dog hair and stuff like that. It just means all the flue gases are actually coming out into the house. So you're automatically going to get CO2 being produced with that. You're also going to be getting moisture produced with it. And if that thing's not burning efficiently and everything the way it should be there, you're also going to get carbon dioxide. Okay. You know, carbon dioxide, we know the dangers of that. It's something we don't want to have in our house, but we also don't want to have all that moisture from those combustion gases and stuff there off that being dumped out into the household. A lot of times you go into a home there that has an unvented heater, whether it's gas or they got kerosene heaters or anything like that. Those are unvented combustion appliances basically in there and stuff. And a lot of times it's common to see a lot of moisture, sweating and everything around on the windows and stuff like that. And that's coming directly from the moisture being released out from the this unvented combustion appliance. You know, you look at a car there, for instance, there when it's a little cool outside and stuff there, you typically see steam and everything coming out of the tailpipe. Well, that's all the moisture there that's being produced from the combustion process there and stuff. That same thing's happening in these things here, except it's just coming right out into the house. And of course, the temperature in the house is a little bit warmer, so we don't see that moisture coming out as steam. You know, if there is an unvented heater there and stuff, it needs to have this ANSI number on there. Make sure that it's actually approved unvented heater, or a vented decorator heater. Here's another one on that. And again, the acceptable documentation, written or recorded record, evidence of location of the unvented appliance, and written and recorded records of evidence there the equipment has that ANSI listing on it. And written and recorded evidence of the total appliance input and homeowner notification if the appliance is not listed. Combustion air sizing on that. And before we get into this here, why don't we just take a 10-minute break? And we'll just meet back here at 11 o'clock. Yeah, it's positive. Yeah.
Hey, Jamie.
Yeah.
If they have an unvented gas space heater in the garage, I've had a few arguments over this one because it's the main heat source, and it's not inside the livable space. Do we still have to disconnect that?
Yes. I mean, that an unvented space heater can't be left as the main source of heat in a home or primary source of heat. So.
Even though we're not insulating it, counting it part of the house?
I mean, are you just talking about it's the main source of heat for the garage?
Correct. Yeah, that's all it's for.
Yeah, I mean, you could leave that in there. You just got to make sure that the garage is sealed off thoroughly there from the home. And I do some consumer ed with them there. So
Okay.
most of the time, those unvented space heaters, if you read the directions with them, they'll tell you to crack a window when you're operating those and stuff. That's to allow for a couple things, combustion air, and then for the flue gases to actually have a point of exit. So.
Okay. All right. Thank you.
You're welcome. Yeah, and I'm actually looking in the field guide there. I know we had that question about atmospheric. And if you actually look in the field guide on page 244, table 8.3 on that, you know, our atmospheric appliances there, that's like our atmospheric water heaters, an old atmospheric furnace, we have that, or an atmospheric vented space heater in there. The oxygen level is actually 5 to 10% on that. So, and then the 80 plus there and the 90 pluses are 4 to 9. Well, hey, Dean, I'm waiting on mine too. Are you bringing them or what?
They'll be right there.
All right. So, all right. You know, if anybody stepped away there and stuff, I did grab a field guide there and confirm that the atmospheric there and stuff there is actually 5 to 10%. So on that, and again, that was on page 244 of the field guide on that. Study state efficiency 70% or so. Then the 80 and 90 plus is there, they're 49% on the oxygen. So. All right, going to talk about combustion air sizing here a little bit. All right, one of the methods we can do there is indoor opening sizes and locations. And there's 5 rules based on the national code there, requirements. One is openings must have a minimum free area of 1 square inch per 1,000 BTUs based on the total BTU input value. One opening must be within 12 inches of the top of the closet or enclosed space, and one opening must be within 12 inches of the bottom of the closet or enclosed space. And this is when we're connecting spaces there on the same story. For instance, if you had a partially finished basement there and you were trying to combine the finished part of that basement in there for combustion air, this is the formula you'd use. The next one there is when we're combining spaces on different stories on that. And basically these spaces can be combined as part of the same total area where they are connected by openings in doors or floors having opening free areas of 2 square inches per 1,000 BTUs based on the total BTU input value, okay? The minimum opening size of the air openings must be 3 inches or larger. Again, that is right out of the NFPA 54. The requirement is interpreted as meaning an opening of 3 inch by 3 inch. So a door with a 2 inch undercut could not count, but one with a 3 inch undercut would. And I don't know if you want to undercut any door 3 inches, not even 2 inches on there, in my opinion. But, you know, that's where I would be looking at something else besides undercutting a door. Going with the outdoor combustion air on there, you got 2 permanent openings on that. The first method is using vertical ducts. And when you're using vertical ducts there, you need to have a minimum free area of 1 square inch per 4,000 BTUs based on the total BTU of the input value of the appliance on there. So that means for every 4,000 BTUs there and stuff, you need 1 square inch of net free vent area going in there. The second one, openings in horizontal ducting must have a minimum free area of 1 square inch per 2,000 BTUs based on the total input value in there. So again, these are ducts that's going to be running horizontally and stuff. You know, you'll run into these quite often there when you've got them in a utility room there up on the main living area of the home on that. A lot of times you'll see that. A lot of times they're not real practical for a basement and stuff because basement's down below grade. It's kind of hard to get the horizontal ducting in there. So outdoor combustion air, again there. One opening air must be within 12 inches of the top of the enclosure on that, and one must be within 12 inches of the bottom of the enclosure. Spaces can be combined as part of the same total area when they are connected by openings in doors or floors having opening free areas of 2 square inches per 1,000 BTUs based on the total BTU input value. And when we're talking about the 1 permanent opening method, again, you're going to have 1 permanent opening within 12 inches of the top of the enclosed space on that, and that can either be horizontal or vertical, okay? this is where we're going to use just one pipe. There's a couple exceptions to this here. If you're going to use outdoor combustion air, this is probably the preferred one because you're only making one opening to the outside. But again, there's a couple things that you've got to meet. The appliances must have a clearance of 1 inch from the sides and back and 6 inches from the front of the appliance. Okay. And if you look in about any furnace cabinet there on the data plate, it's going to tell you what those clearances are supposed to be on that. That pretty much aligns with what's in the NFPA 54. And the duct must have a minimum free area of 1 square inch per 3,000 BTUs based on the total BTU input value of all the appliances in the enclosed space. Okay, so let's say we had a 100,000 BTU furnace and a 30,000 BTU hot water heater in there. Be a total of 130,000 BTUs. I would just divide that number by 3,000 to give me how many square inches of net free vent area that I need, okay? When there's more than one vent connector, the size of the opening must be equal to or larger than the area of the vent pipes. So whenever I've got like 2 appliances, just like I was saying, that furnace and a water heater in there, whatever that opening I'm making to the outside, it's going to have to be larger than the area of both the furnace and the hot water tank combined in there, okay? Even if I calculate something that's smaller, it's not saying that I can't use that method. I just need to make my pipe bigger. Because one of the reasons I want to do that there is if the opening there on the vent pipes are actually bigger than what the combustion air duct is on there, nature always likes to take the path of least resistance, and basically the appliances are going to try to pull combustion air back down its own vent system instead of pulling it through the combustion air pipe. Okay, that's the main key to that. Combination indoor-outdoor combustion air. Again, all the directions previously provided in this section there, your NFPA 54, need to be followed for individual types and sizes and locations, including equipment spacing requirements. The calculation is done by finding ratios for each type of combustion air and using them to find the size opening needed to provide the remaining outside air. So basically what you're allowed to do is take advantage of the space that you've got. And this works really good when you kind of have a large area, but it's just not large enough there to actually take care of the appliances. Instead of bringing in 100% of that combustion air back there, we only have to bring in the combustion air that we're actually lacking. We're actually able to use the combustion air that's in that space. And going through this ratio here, again, this is where you take the interior space volume there in cubic feet and divide that by the required volume. It gives you a ratio on there. And basically the outsize reduction factor equals 1 minus the ratio of the interior spaces. I mean, one of the easiest things there is to figure out how much volume you need, okay, and how many BTUs that's going to handle, and then subtract the amount of BTUs that space will handle from the BTUs of your appliances, and then solve from there. And again, the outdoor minimum size openings must be in accordance with the 2 permanent or 1 permanent opening size procedures, as we talked about here earlier. So you'd either be doing 2 horizontal ducts, 2 vertical ducts, or 1 permanent opening in order to bring in the remaining combustion air that's required. You know, some other requirements there and stuff, you can use a mechanical fan for combustion air in that. These are considered engineered systems on that, and they need to be approved by the authority having jurisdiction, okay? You know, we use these in weatherization there fairly often, a fan and a can and stuff. They are expensive, okay? And basically what this is set on there is when the gas valve fires off, basically it kicks the fan on there to bring in combustion air for the combustion process. Again, it's a mechanical device there and stuff. It could, possibly fail down the road. It's costly, but it is an option. Sometimes you get in a situation where you don't have any other choice but maybe do something like this. Screens, louvers, and grill sizing, okay? All of them there need to meet the manufacturer's free area should be used to determine the opening size, okay? Typically, when you look at a louver or a screen or something, grills like that, they're going to give you a net-free vent area on that. As long as that's available, use that. But if it's not, in the NFPA 54, they give you some default values to use. Like if you're using wood louvers, you consider there you only have 25% of the opening of those louvers in wood. So that'd be like putting in a louvered door, okay? Well, only 25% of that door area, there's actually your net-free vent area on that, because that's taking in all the wood slats in there and stuff like that. And if you look at a louvered door like that there, you've got the outside door framing going around there, and then one running across the middle typically, and then those slats going in there. So, it's going to take a pretty good door maybe to get the amount of opening that you actually need in there with only having 25% of that opening available. If we're using metal louvers, we can use the default value of 75% of the opening. So we would have 75% of the opening there in that grill available to us. Much smoother flow, a lot less of a restriction and stuff there on the airflow with metal louvers. Test screens will have a minimum mesh size of 1/4 inch. Okay. And basically this is where you're going to put those on going to the outside of the building, so we don't get birds or squirrels or something trying to crawl back into that combustion air opening. We can't have something with a damper or something on there that's going to shut on there, because if it shuts, it's going to pull shut when you're pulling in the combustion air, and that's not what we want. So we'd be looking at some type of screen just to prevent pests from being able to enter in through that pipe on there. Now, if one is terminating into the attic, we do not want to put any screening or anything on that in the attic on that. That is supposed to be open. Another option you run into, not so much in residential stuff, there's motorized louvers. They can have an interlock switch with appliance to keep the burner from operating when it's closed. Sometimes you run into these with boiler systems and stuff. They'll have a vent damper on them there and stuff that basically it won't operate there. Kind of the same principle, if that damper's closed there and everything, it won't allow it to run. Doesn't really have anything to do with the combustion air, but a lot of times you'll see it in a commercial thing where they've actually got motorized louvers that'll open up there as there's a call for heat for that burner to fire off. And again, some acceptable documentation there. You want written records there of your combustion and appliance zone area measurement calculations for your combustion air. Written recorded records of the outdoor air requirements covered in this section have been met. So if you need to do any calculations for combustion air and stuff, you need to have that in there in the job file. And written or recorded records of the homeowner notification that the items not in compliance with the outdoor air requirements covered in this section have not been met. Okay. Basically, we have to resolve a combustion air issue if we run into one in weatherization. So it's important there and stuff that we have different options that we might be able to present to the homeowner. That's the reason why when you guys come to class, we run through all these different options for combustion air and stuff with you, because every house is different. And, the homeowner might say, well, no, I don't want you putting louvers in my door at the top of the stairs. So then you have to come up with another situation, okay? What you want to do is have those possibilities. You can say, well, okay, you don't want me to do this. Can I do this? Okay. And, you know, that has to be met. That's a health and safety issue and stuff. And that's something that has to be done before you can proceed with weatherization. So the homeowner needs to be notified of this and agreed to have these procedures done in order for the weatherization to proceed on that. So it's really important for the initial inspector or energy auditor there and everything to actually convey to them that, hey, this is something that's going to have to happen before we can do anything else. Your combustion air ducting, okay, what are you going to run it out of? Oh, here's a nice piece of galvanized pipe, okay, that's one option. And actually, according to the NFPA 54 there, your ducting for combustion air must meet the following 8 requirements. It must be constructed galvanized steel or have an equivalent strength and rigidity and resistant to corrosion, okay? It is possible, instead of possibly using steel, is to use PVC pipe, okay, and stuff in there. That's gonna meet those requirements in that. Where there's more than one fire block is removed in the joint space, an open stud area may be used for running the duct, okay? It says running the duct, cannot be, you know, the space can be used to stick the duct through. It does not mean that you can use the joint space as the duct. Duct must end in a location where it is not going to be blocked off, okay? That's one thing there where you're talking about the going outside. We want it up above grade, up above the snow level and everything like that. That's one thing that they're referring to. Duct can only be used for one space. Basically, that one duct is going to be there to take care of one space. You cannot put that same duct in 2 different rooms on that. You need to run 2 separate duct systems there to take care of the combustion air. And one duct cannot be used as both upper and lower, okay? So if you're doing, say, 2 vertical ducts, you can't use one duct and run it in and put a grill coming off of it and then run it the rest of the way down for the bottom thing. You need to have 2 pipes or 2 ducts running in there, one terminating within 12 inches of the top of the enclosure and one within 12 inches of the bottom. Ducts terminating in vented attic spaces must not have screen on them, okay? We don't want anything up there where it could block that combustion air off. Horizontal ducts must not slope downward there toward the combustion air source on that. So they're actually wanting them to kind of slope slightly down to the appliance on that. Cavity space in a building or extra piping in a chimney cannot be used to supply combustion air. And here's showing an example here and stuff. This is showing a vent off a 90 plus furnace, 2 pipe 90 plus furnace. And you can see here in this picture, they've got their air intake. This is their combustion air.
To lay down.
And basically this is their vent. And basically whenever you're dealing with a 90 plus furnace there and stuff, you always want to follow the manufacturer's venting instructions. They're not really covered in the NFPA 54 on that. Basically those are considered PMI. And if you're unmuted, could you please mute yourself? Got some background noise going on. And one of the big things talking about, here's another example here. We got the vent, and sometimes they're instead of having an elbow on them and everything, they want a T put on them. Here's their combustion air inlet. This one's got a screen on it. Now, one thing I've run into issues with there, if you're around a place there that's got high moisture, I know like with us here, we've got the Ohio River down here close and stuff, and I actually installed a 90+ furnace in a house there one time right on the river. And every morning when it was cold and that river would get foggy and stuff, it took me a couple visits before I realized what was going on. But basically, this screen in this combustion air inlet was icing over. Once I figured out what was going on, I just popped that screen out of that combustion air inlet, and I never had any more problems with it. But, you know, that's one of the weird circumstances you kind of run into with that. So the screens, you know, sometimes they come with them. It's an option in that, but they're not always required unless the manufacturer's required. But the finished ground level there must be at least 12 inches below the combustion air inlet or the vent on there, okay? And basically, anytime it needs to be above the anticipated snow level in the area. You know, snow level in Ashtabula, the anticipated snow level there is probably going to be a little higher than what it is in Cincinnati on that. So their vent pipe's probably going to want to run up there a little bit higher. Atmospherically vented appliances. The technician needs to document whether the combustion appliance venting system shows evidence of lack of maintenance or wear problems that could cause performance problems such as blockages, soot, corrosion, rust, oxidation, improper support, slope, and/or termination, or insufficient draft. And here's showing an example. This is a horizontally installed furnace here and stuff. You know, basically they're wanting you to make sure you've got a 1/4 inch slope going back to the appliance on that, and the termination going out. Water heaters. Talking about a fossil fuel water heater, okay? Basically here, you know, this is a picture of a Rheem Platinum, Performance Platinum here. This is a pretty top line water heater that they got here and stuff. So on this, basically when you're dealing with water heaters, some of the things you need to look for on this here is any signs of spillage or backdrafting and stuff going on. You know, a lot of times here you can see rust up underneath the vent diverter on that. With the thing not running, you can stick your finger up underneath there and see if this is real rusty and stuff. If it is, that's showing that there's a good possibility that this thing has been spilling or backdrafting sometime there in the past. Another thing, this one here doesn't appear to have rubber grommets on there, but a lot of times you'll have rubber grommets around the top, and they might appear to be melted and so forth on here. That's another good sign. Any rust damage on the top of the water heater and stuff like that. You know, if you can't see any signs where there's been a water leak there that's caused that, that's probably come from spillage in there. The other thing you want to pay close attention to is the temperature pressure relief valve. Okay, make sure it has one. Make sure it's got a drain tube coming off of it that is either soldered copper or unglued plastic. Okay, they have those drain tubes there and stuff that's made out of solid piece of plastic there that has a metal threading pressed onto it and stuff there where it'll screw right into the TP valve. Plus you want to make sure that it has the proper rated one in there, and it should be at a temperature of 210 degrees Fahrenheit and 150 psi, and that's according to the Ohio Plumbing Code in there. Electric water heaters, not necessarily so much to look at about the venting and stuff because there is no venting. Okay, you want to look at the wiring connections on an electric water heater. You know, this one here and everything, you can see it's actually got conduit coming in where it's tied in. A lot of times it's not uncommon to see the wire sticking up out of this little junction box here and just wire nutted together. And this thing does need to have a temperature pressure relief valve. I know it's a little bit hard to see on this, but it's right here, and here is the drain pipe coming off of that. That is soldered copper, okay? And that's allowed. We don't want any glued fittings or joints on that and stuff there, because the glue, if you're using CPVC or PVC, is not meant to withhandle that temperature or pressure there that it might see. So it'll fail. Tankless water heaters, okay. You know, they have these in both gas and electric on there. You know, these things are pretty good. They're better than the old storage water heaters because you don't have all the standby losses with them. This is only heating up the water as it's being used. When a faucet's turned on to the hot water there and stuff, the water starts flowing through this and is heated up. Whereas a storage tank water heater there and stuff, it's sitting there holding that water in it. Even if it's not being used, it's going to have to continuously be reheated in there. So you get a lot of standby losses in those type of water heaters. Another one there is a point of service water heaters. These are ones that's typically like located underneath a kitchen sink or something there. And basically they're just meant to supply hot water to that area there that it's located in. Could be a kitchen sink, could be a bathroom, whatever there. You know, they call them point of service or instantaneous hot water heaters and stuff there, same thing. And they can be electric, most commonly is what they are. I've actually seen little gas ones as well. And a lot of times this is used when somebody might have a long run from their water tank and everything there. And, you know, it might take them a few minutes to actually get hot water going to their kitchen sink or something. They'll install one of these so they don't have to run their water as long. Again, they're looking at the safety valve, temperature pressure safety relief valve on here, making sure it's got the proper rating on there. Making sure it's got the proper discharge tube on there, either copper or a solid piece of plastic in that. And they do have pieces of plastic that's actually got the bend made into them there and stuff where they can screw right into the temperature pressure relief valve. And they make ones that come out of the side and would run straight down as well. A safety drip pan, okay, on there and stuff. You want to sit there and make sure that, you know, you got a drain pan, especially if it's in the living area of the home. That's definitely a good possibility there. You want one. If it's in a utility room or something, you don't want this hot water tank there to start leaking and, you know, ruin everything there on the living level of the house there and stuff. So put one of these on here and have it run to the drain there and stuff. And a lot of local jurisdictions and everything, it's absolutely required to do that. I've even had people tell me a local code enforcement person's making them install these on mobile home water heaters. Whereas a mobile home water heater, if it's a gas water heater, is a little different because they pull their combustion air from the bottom out of a pipe that comes down and runs through the belly of the mobile home. In order to put one of these drain pans on underneath one of those, you have to cut a hole in it, which doesn't make a whole lot of sense. So, you know, it might stop a little bit of the water from coming out, but it's definitely not going to catch it all. So, because you cut a hole in it. Signs of damaged appliances on here. You know, again, this is one I was talking about, a water heater here. This is a perfect sign of where the thing has been spilling for a long time. See, there used to be rubber grommets around this. They're all gone, melted off, burnt off. Moisture's been rolling out here and caused the top of this tank to all rust and everything. And let me go back here. And you're looking here at the burners of the furnace here and stuff. Basically, you want to be sitting there, look and see if there's any soot built up down around the bottom of the burners there and stuff, rust, corrosion of any type. That's a sign that there's been problems going on with that furnace. And I don't see much soot. Might be a little bit down here in the bottom around this burner, but I do see quite a bit of rust in around this and stuff. So that's kind of a sign there that there might be some type of venting issue going on in that there that's causing that. And from the looks of this, I'm going to say this is probably an 80 plus furnace, because it doesn't, could be an early stage 90 plus, but I don't think it is, because it's got in-shop burners in it. But yeah, there's rust. I'm going to want to do some investigation of what's causing that rust. And most of the time when you see rust on this and stuff, it is something to do with the venting issue going on. And it could also be that the thing's burning at too high of a steady state efficiency, because the gas pressure is not correct on it, and it's causing condensation in the venting system. So when you see something like this and stuff there, you need to do some further investigation to see what's going on. Another thing you run into in there and stuff, you know, people store stuff. You know, they store it in the basement, they store it in their utility room, out in the garage and stuff there. You know, we don't want to sit there and see gas jugs in around our combustion appliances, okay? Batteries, pesticides, you know, any mercury containing thing, fluorescent bulbs, any type of toxic chemicals or paint or anything like that, because those could possibly okay. Well, obviously, it just told me that I was done with my screen share. That was the end of the PowerPoint anyhow. That was the last slide. Has anybody got any questions right now? If not, I actually have another video of me going through worst case draft. And I'm going to play that there for you. And then we'll see if there's any questions after that.
Hello, I'm Jamie Marshall. I'm going to be going over worst case draft testing with you today. Jim Hall's back here operating the camera behind me. I'm going to be going over the most current version of worst case draft on there. Basically, we're in our prop house here right now and everything. We're going to be walking through this and going step by step. If you look at the worst case draft form, if you're familiar with that, the first thing you want to do is put the date down for the day on that, which I believe today is the 30th of March. Okay, put your name down, of course, job number. And then the first thing I need to know there is the outside temp. So I'm going to go check the thermometer out here that we got out here at the prop house, see what the outside temp is. And it looks like we have about 68 degrees outside. So, and now that I've done this here, I'm going to go have this door shut behind me, because we're getting into the pressurization test here right in step 1 on this form. And basically the first thing that says there is put the house in winter operating condition. That's all the exterior doors and windows shut. So I shut that one behind me. I'm going to make sure the rest of the windows are shut in here. Okay. The line's pulled here. Make sure that one's shut. It is. Got this door open, so go ahead and shut it. And the window there that's in the cabs, it is shut right now too. So I've got this hose here that's already run outside for me in our CAS house. If you're doing this in the field, of course, you're going to have to run the hose outside. Find the best spot there to do it with. You might need some longer hoses there, depending on where your CAS is in the home and where you need to go to get it outside. So, got my DG 700 gauge here on this, And if I look on this, step 2 is actually telling me how to connect this hose on here. I'm going to want to get a reading of CAS, which is this area right here that I'm standing in. It's where the combustion appliances are. I've got an atmospheric hot water tank and an 80+ furnace here with reference to outside. So I can go on either side of this gauge. I can go on the A side or the B side. I got 2 separate gauges here on this. But what I want to do there is sit there and put this hose on the bottom tap, okay? Because again, I want to get a reading of CAS with reference to outside on this, okay? Now, I want to measure my baseline pressure, and I'm going to have to do that with the CAS door shut. CAS door shut, the house is at rest, all the exhaust appliances are off, the furnace, the hot water tank's turned off there where it's not going to fire off. And I'm going to get a reading here. And let me turn the light on, I don't know if that will help in there or not. And I look here, I'm actually getting a reading of 0 Pascal. That's my baseline. Which is typical. I don't have much of a temperature difference between inside and outside on that, so I don't have a whole lot of stack effect going on in this house. So I recorded that there in step 3, again, of this form. I've got 0 on this. Now, if I got an actual reading on this, whether it was positive or negative, I'd want to make sure and put my sign in there, whether it was negative or positive, because that will make a big difference on that. So now I'm actually ready to set up and find out what my worst case scenario is. I'm going to be sitting here going through steps A through F here on this. And in step A, it's telling me the interior door's open, CAS door closed, air handler off, and with all the exhaust equipment on. So now I'm going to go turn on the exhaust equipment in the house, and then I'm going to come back to this CAS area. So in this particular house here, I know I've got a bathroom exhaust fan in here. Got it turned on. I walk over here. I've got
Mention too that it's a
vented clothes dryer here. I'm gonna check that. Always want to check the lint filter in that, make sure it's clear, not full of lint in there. And I'm going to turn that on. Then I've got a range hood on here that's vented to the outside on this. So I'm going to turn it on high on there. Now I've got all my exhaust equipment on that's in this house. I'm going to walk back over here to the CAS. Just let you move back in there. All right, I have my CAS door shut now on that. My exhaust equipment's on. The air handler's off. All the interior doors are open. And if I look right here, I'm getting a negative 0.8. Okay. Now, the very next step on step B here, my house is set up identical, except I'm just now opening the CAS door. So I'll open that up. And give it a second here to bounce out a little bit. And it looks like I'm getting a negative 1 on that. Okay. The next one here, I'm going to be turning the air handler on. So I just turned the air handler on there. Switch is turned off. I'm actually going to pull the filter out. Always want to check the condition of the filter. If it looks slightly dirty, pull it out. So we want to try to get as much air moving through that air handler as possible. Okay. All right. All right. I've got the air handler closed. So I'm closing this CAS door again. And it looks like I'm getting a negative 1.6 on this. I go to step D on here. Now I'm going to be opening the CAS door back up. Okay. That CAS door open. Set here to take a reading. You can see here I'm getting a negative 2.2. I'm going to go through the house and close all the interior doors, which in this prop house here is pretty easy. We only have 2 interior doors here to worry about. One is our bathroom door here, and then the one coming into our front room here. So that's the only thing I need to do is just shut those interior doors. My CAS door is going to remain open, my air handler on. I'm going to take a reading here, and it looks like it's went down to a negative 0.6. Okay. F. Step F here. Now I'm going to close the CAS door. Like that's going to be a negative 0.6 as well. Okay. A couple things I'm going to be looking at here. Step D is going to be my worst case, negative 2.2. Okay. The other thing I want to pay attention to on this here is step C, because when I turned the air handler on here in step C, my CAS went way more negative on this. So that means my air handler is having a negative impact there on the CAS. I want to do some investigation to see what that was. That could be something like unsealed ducts, return ducts there in the CAS. It could be supply leakage there. Our ductwork's going into the attic in there and stuff. It could be that the supply's actually leaking into the attic and causing a negative pressure here. Or it could be the location of the return grills and everything. It could be a combination of things. But here, in the process of doing this job, I'm going to want to figure out what's causing that and see if I can alleviate it. So right now, I'm going to go back here and set up step D. That's my interior doors open, CAS door open, air handler on. So I'm just going to open up all the doors in the house here on the inside. That results in the greatest negative configuration for the worst case on this. And now I'm going to check for spillage and then draft on this and record my final depressurization on this. I'm going to start with the lowest BTU rated appliance there, which is going to be my hot water tank on this. And basically I need to check for spillage at 1 minute here on this. I'm going to use a mirror to do this with. The mirror fogs up there. That means I've got spillage coming out of the draft diverter. I'm also going to be sure to go all the way around this draft diverter because it could actually be drafting up one side and blowing back down the other side. So I'm going to fire off our water heater here. Lit it off. Got a clock right here at the second hand. It was about 20 ampere on that second hand when I was doing that. And I can feel the spillage here coming out of this right now. There's moisture there collecting on top of the water heater. You can see that as I wipe my hand across there. Okay, moisture there is definitely a sign of spillage. If I stick my mirror under there, you notice it folds right up on that. One thing, if you are using a mirror on this, don't just hold the mirror under there. Okay, that mirror will heat up and eventually it'll quit fogging up on you. So I normally just like taking the back of my hand, holding up here and stuff. If I quit feeling any moisture or heat on the back of my hand, I'll go ahead and take the mirror and put it down. But I'm getting right at a minute here right now. And you can see I'm still getting spillage on this mirror. So this thing, I'm going to record down here that it has failed the spillage at 1 minute. Now, I've got another minute here that I'm waiting on and stuff. What I like to do on this here is go down to step 9 on this form. And it says record cast outside pressure on that. Well, I've already got my gauge hooked up here. Basically, it's a negative 2.3. So I'm going to write that down there. And then I'm going to get my draft probe hooked up here to be able to take a reading in this when I get to the 2 minute mark. And when I take draft, I'm getting a reading of draft with reference to the cast. So my hose is going to be on the top tap. And the nice thing about those gauges, you've got 2 separate gauges right there to work with. So I'm right at 2 minutes there now. Stick that in. I'm actually getting a positive 1.5. Okay. So put that down 1.5. Okay. Now I'm gonna shut down my water heater here. Okay. Now I'm going to move over to my furnace. Now, with this being an 80 plus furnace here and stuff, I don't really have any way to check spillage on this other than where it's commonly vented at the hot water tank here. I can check the draft hood of the water heater possibly on this. If you've just got an 80 plus furnace that's vented by itself, there really is no way to effectively check spillage. Just measure your draft reading on that. If it's drafting all right, that's going to let you know on here. So now I'm going to turn the furnace on. This is one key thing right here. Fire this furnace off. It's going through its purge cycle there and everything. The blower shut off on this right now, okay? When this thing actually lights off and everything, it's going to be about 30 to 45 seconds before that blower kicks back on. I don't want to take any readings on this or anything until that blower kicks on, because the worst case was with that blower on that air handler. And this 30 to 45 seconds here can feel like an eternity as you're sitting here waiting, but it is important to wait until that kicks on. All right, that's kicked on. I'm going to sit here and check. I have no spillage here coming out of the draft diverter of this water heater right now. So now I'm actually going to take a draft reading on this. And if I look at my draft reading on this here, I am getting a negative 3.9, negative 4, 4.1. All right, it's varying a little bit there. I'm going to call it a negative 4. Okay. So I got a negative 4 on this. While I have appliance 1 running by itself, I'm taking another reading, CAS, with reference to outside. And on this here, it is actually negative 2.4. Okay. Now I'm going to set this down. Now I'm actually ready to do appliances 1 and 2 together on this. So I'm going to fire the hot water heater back up. Furnace still running. And I'm going to check for spillage at the water heater. Okay. The water heater's running. I'm not getting any spillage when it's running in conjunction with the furnace on this. Okay. So basically, this is going to pass the spillage on here. Now I'm going to take a draft reading with both appliances running. Draft on appliance 1 here. We can see that looks like a negative 0.4 on that. So I'm going to write that down. For negative 4. Now I'm going to check the furnace. And if we look back at the furnace, it looks like it's drafting about a negative 5.7, 5.6, right around in there. So, 6, okay. Now I've got all my draft and spillage testing done here. I need to take one more reading in CAS with reference to outside for both appliances here. And as you can see, I'm getting about a negative 2.5 on this. 2.5, 2.6.
That on step 9?
That is on step 9. And now I'm going to turn these appliances back off. Actually, turn that air heater off. So now let's step out here. There's a little bit more room. The air handler's not making quite as much noise. And I'm going to point out here on step 9 where I recorded these CAS outside readings. Okay. I recorded that, and then I took my baseline reading of 0 from step 3 and moved it down to the second line underneath each one of those, under appliance 1, appliance 2, and appliance 1 and 2 by itself. Being our baseline was 0, those numbers aren't going to change it.
You see how those numbers didn't change? 2.3 minus 2. Or minus 0 is 2.3 negative.
Now that I've got this done, what I'm going to do here, okay? Appliance 1 failed spillage. All right, I've got to see if I can do something to possibly alleviate that issue there on that. The other big thing is I'm going to be looking at draft readings, okay? Appliance 1 there, it had a positive draft. Well, it failed spillage. So basically, appliance 1 operating by itself failed. Okay, all the way. Appliance 2 had a negative 0.4 draft by itself. I want to flip over here and look at our handy dandy draft table here on the back of this. Okay. And if I look at that there and stuff, I'm going to be looking for the temperature range on this here. The temperature was 68 today. I'm going to be looking to 68 to 61. All right. I've got gas appliances on this here and stuff. So that is telling me there that I only needed a negative 2 Pascal for today. Okay. With that being said, I look here, appliance 2 by itself was a negative 4. And appliance 1 and 2 was a negative 4 and a negative 5.6 when they were together. So Appliance 2's fine. Appliance 1 is fine when appliance 2's running at the same time on this. My CAS depressurization, if I look at that in note 2, okay, for the appliances I had in there today, it's a -5. I had an atmospheric water heater, so it's a -5. Basically, I look at these numbers, the most negative force I had there was a -2.6. So I'm good on that, my CAS depressurization on that. But again, the other big thing there that I really want to look for there is what caused that hot water tank to fail the spillage and the draft rating by itself. I'd be looking to see if it was excessive exhaust going on in here that caused that. Whether it's leaky ducts that caused this issue on that, and try to figure that out. It doesn't seem to be a venting issue because the appliance run all right there when appliance 2 was fired up, and it actually helped heat up that vent system. Is the reason why appliance 1 started drafting all right. Now, you know, this is your typical house. Like I say, you have to do a little bit of investigation there and know what's going on in this. Pretty much the way we've got this house set up right now, we have a lot of supply duct leakage going up into the attic, and basically that causes a pressure imbalance down here where it's a lot more negative down here in the main part of the house and in the CAS than what it should be, because we have a lot of supply air leakage up into the attic on that. I already know that. We've already investigated it and know that's what the cause. Now, if we was doing this here and that would have just had a 90+ furnace in there, 2 pipes run to the outside, I wouldn't have had to do this, okay? If that would have had that and an electric water heater in there, I would have not had to do worst case drafting today. I could have just wrote on my form, 2 pipe 90+, electric water heater, and done, okay, on there. If that 90+ only had 1 pipe on it, okay, which the first generation of 90+ furnaces only had 1 pipe on them. And even some of the newer ones there and everything right now, you can still install those with only 1 pipe. It's just the fact that the installer kind of being lazy there and not running that second pipe out. But that's something to pay attention to. If it was just a 90+ furnace in there that only had the exhaust going outside, I'd want to look at that there, and I'd still have to do my depressurization level on that. And if I reached a -10 with that 90+ furnace in there, I'd have problems, okay? Big way to take care of that is running that second pipe outside if that furnace is so equipped. If that furnace isn't equipped, it might be a good candidate to look for a change out, because that furnace is probably 30 years old now, so in there. Anything else?
If you could just go over the air handler impact, or not the air handler impact, but where the actual water heater failed, that they could actually go back and turn some fans off to see if that was a problem.
Yeah. You know, one thing, I kind of mentioned this before here, where the water heater failed by itself. One thing that we could do there is just go down and, you know, turn off 1 exhaust fan at a time, see if that takes care of the issue there of the water heater wanting to backdraft by itself there. And if that doesn't do it, then I can start looking at maybe duct leakage or something like that that's causing the issue on that and stuff. Like I say, we've done a pretty good investigation of this prop house here, and we know we have a lot of duct leakage up into the attic on this, so we know that's what causes the problem. Another thing there that we have going on here too, you know, here's our CAS door, okay, and right there's a return grill, all right. That can have an issue on it there too. If we notice step D on our form was our worst case scenario, well, step D is with the CAS door open, okay, interior doors open and air handler on. So that return grill is definitely having a big effect there when that CAS door is open on that. So, you know, it made almost a half a pascal difference just that CAS door being open and shut on there.
Okay, I think Jamie's covered pretty much the basics. And we know that down the road that this form is going to change again, but in reality, you're still going to be doing basically the same stuff if you just follow the steps, one step at a time. And again, please keep us in mind. Give us a call. We'll help you out with some TNTA. I guess that's it.
All right. Does anybody have any questions? I know you guys have seen that worst case draft video before, but I am going to be doing one here with the new form that we're going to be doing, starting a new program here on that scene, so you guys can see what the differences and stuff are. So on that. Anything? You still awake there, Dean, and sitting on the beach?
Barely.
Barely. You look nice and relaxed there. So
Yeah, I wish I was there.
yeah, me too. So
Good job, Jamie.
all right, thanks, Dean. Mark, basically what we're doing, we're trying to align the new worst case draft here that we're going to be doing for the weatherization program more in line with the BPI one. So you guys basically aren't going to have two different forms there. You're going to have to try to deal with. So yeah, it's coming really close to what BPI is. If you guys have come and took our, oh, he's probably typing that when I said that. He probably sat there and if he took our EA or QCI test, basically the new form is based off that. You're still going to have the steps A through F there as far as the setup and everything, but we're really just going to be looking at spillage and measuring the CO and stuff on there in that, and not necessarily requiring a draft. We're still going to have the draft tables on there. Okay. You know, me as a technician, I want to know what the draft reading is on an appliance. I want to know how well it's drafting, but the spillage is going to be the big thing there. That's what's actually in the national SWS. That's what's in actually the NFPA 54 as well, and BPI standards. So spillage is the big thing that we're going to be looking at on that. And we're kind of doing away with the depressurization levels. There will be no 5 Pascal for atmospheric furnaces or 10 Pascal for fan assisted or sealed combustion on there. There will be 5 Pascal limit on a fireplace or wood stove still in there, as long as it's not sealed combustion. So the depressurization limit's pretty much going away, other than, you know, solid fuel appliances. Those are the big changes that's happening. So, anybody got anything else? Yeah. Well, according to Mr. Hall, he just informed me it's margarita time. So, Cinco de Mayo.
Cinco de Mayo.
Hey, if anybody drinks beer there, you know, you drink Corona, just don't catch the Corona. Okay. That's the key. So, nobody's got any questions. I'll let you get on with your day today there. Everybody stay safe, and hopefully I'll see a lot of you back here tomorrow.
Thank you.
You're welcome.
Later, man.
See ya. Hey, Ryan, you take care, bub.